Lesson 1-3, let's begin. So take a moment and look at problems 1, 2, and 3. You will see that this is a bit of a warm-up from what you have already been working on. So I want you to go ahead and work these problems out, and you will see that there's a table there on the bottom right where you will put your answers to the interval notation of domain and range. So go ahead and do that. Okay, so let's begin. Hopefully you paused the video and you are ready to go over your answers. So if you are looking at domain for problem number 1, remember domain has to do with the x values that are being used to plot the points of this curve. So we are going to look at the furthest left to the furthest right value that helps you graph this curve. So what is the furthest left value that you can see for this half circle, so to speak? Well, if we're looking at the x-axis, the furthest left you can go is -6, and all this curve is being populated until you arrive to +1. So all values between -6 and 1 is going to be your domain. So let's go ahead and write that down. So -6 all the way to +1. And we need to make sure we put brackets since those values are included, are part of your function. When it comes to range now, range has to do with the y-axis. So we're looking at the y values, and we want to know which low to high value are being used on the y-axis. Well, the lowest values are occurring right here and here. And if you look at it with respect to the y-axis, our y value is going to be 0, and the highest value is going to be right here at around 3.5. So the lowest y value was a 0 all the way to 3.5 on the y-axis. Okay. All right. So that's the domain and range for that one. When we look at problem number 2, now, if you look at problem number 2, I want you to notice something. So let's talk about this arrow right here before jumping into domain and range. Sometimes students, when they look at this arrow, so to speak, if I asked what direction is that arrow going in, most students will just say it's going up, okay? And even though they are correct in saying that, what I need you to start thinking about when it comes to those arrows is that they are actually doing more than one thing as far as movement, all right? They have two directions. This arrow is going in the upwards direction, yes, but it's also, whoops, let's revert that. It's also going left continuously. So what you have to ask yourself is, if I ask you what direction is that arrow going in, you have to ask yourself, well, with respect to what? With respect to the x or the y-axis? Horizontally, with respect to the x, it's going left. Vertically, with respect to the y-axis, it's going up, okay? So anytime you guys look at the arrows of any given function, please make sure you understand that it has two directions. So you need to decide, am I looking at this from the respect of the y-axis or the x-axis? So why do I ask that? Well, we're getting ready to do domain. So when I'm looking at those graphs, domain means I'm looking at it with respect to left and right movement. So this graph, is this arrow moving left or right? Well, currently it's moving left. Is this arrow moving left or right? Currently it's moving right. It's moving left negatively forever, and it's moving right positively forever. So the domain is going to be -infinity to +infinity. Okay. Now let's look at range. Range has to do with up and down movement. So let's look at this graph. let me erase the markings here. Up and down movement. So this this end, is it going up or down? It is currently going up forever. So that is positive infinity. This arrow, is it going up or down? So here's what I need you guys to understand. For this particular graph, it looks like it's going down forever. It is hard to tell, but if there's two answers I can allow you guys to make here. But if you pictured a horizontal asymptote right here, okay, that means that if you have a horizontal asymptote at y equals -8, that means the graph keeps going down, but it will never ever pass that -8 wall. So if you did visualize a horizontal asymptote here, I want you to put your answer. Notice I wrote it in purple. The range would be, the lowest value would be -8, and because -8 is a asymptote, you would put parentheses, and the highest value would be positive infinity. Hold on, my pen's giving me problems. Positive infinity. Okay, so that's what it would be if you visualized a horizontal asymptote. Now, if you did not visualize a horizontal asymptote when you first looked at it, you would have told me that it went from negative infinity to positive infinity, because what you did is you visualized this graph moving forever down, lower and lower and lower. You visualized that this arrow here, as far as negatives, it kept going downwards. Okay, so I will accept either one of those answers. Again, if you did use a horizontal asymptote, then your lower bound would have been a -8. Last but not least, on number 3, I did expect you to identify the horizontal and vertical asymptote of this rational function. So here you would have had this horizontal asymptote. Go ahead and draw it out if you didn't. Horizontal asymptote going through y equals 4. And you should have visualized a vertical asymptote right here at, I'm going to put VA at x equals -1. Okay, so let's go for domain. So domain has to do with my x-axis. So I'm looking at the x-axis here. So I'm going to visualize this person is standing on the x-axis here, and they are walking this direction. And notice they're walking from the negative infinity, but when they get to this wall, they have to jump over that wall, right? That stick figure has to jump over that wall. So we are going to start from negative infinity, go all the way to -1, and jump over the wall to then start over and keep walking in the positive infinity direction. So we're walking along this x-axis because we're doing domain. So how do we write this out in interval notation? Well, let's say that I started from the left at negative infinity and I kept walking all the way to -1, and I'm going to close parentheses because it's an asymptote, union, and then I jump over the wall and I'm still close to the wall at -1, but I'm going to walk away from it and keep going in the positive direction. So that's how you should have written it. So I'm writing it one above the other because I can't write it side by side. There's not enough space. In the same manner, we're going to do range. That means vertical movement. So I'm starting from below, right? And I'm walking, and then I hit a wall. I have to jump over that asymptote wall, and then I keep walking, right? So I used all the values of y except for 4. So let's write that. I started from way down below, went all the way to 4, jumped over, so I have to skip 4, so that's why I'm putting parentheses. I started with 4 on the other side of the wall, and I kept going. And so that's how you would do these These are called rational functions. Rational functions. You will learn how to graph these in the future. Okay. All right. So that was kind of a warm-up review of what you guys have done in the previous sections. Let's move into the new stuff, okay? So you have already reviewed how to identify if a function is not a function. Or sorry, you have learned how to identify whether or not something is a function. You have used tables, mappings, graphs. You've done all of that. Specifically, when you use the graphs, you would use the vertical line test to test whether or not it was a function. Now, here's what I want you to recognize you're going to do now. If you are checking, let me see, if you're going to check to see if it's a function or not, okay, function or not. If you answer no, okay, you are done. There's nothing else to do. You cannot check for one-to-one oneness when it comes to the answer no, okay? Now, if you check to see if it's a function and you answer yes, okay? If you answer yes, that means I need you to now check and see if it's one-to-one, okay? Only if you answer yes do you check to see if it's one-to-one. So let's read this paragraph, okay? All functions that pass the vertical, let me actually read what the words are. All functions pass the vertical line test. So you've already passed the vertical line test through this part, okay? But only one-to-one functions pass the horizontal line test. So what that means is, if you say yes, I need you to check to see if it's one-to-one by doing the horizontal line test. The horizontal line test works exactly like the vertical line test. Here you go. Here it says, with this test, you can see if a horizontal line drawn through a graph cuts through the function more than one time. If the line passes through the function more than once, remember, you're only doing it with functions, that means that the function fails the test and is not one-to-one, okay? So if you end up with a function, I want you to do the horizontal line test. And if it touches more than once, you're going to tell me it failed and it is not one-to-one. If it touches one time using the horizontal line test, then you will say yes, it is one-to-one. So let's practice that knowledge, or apply it, I should say. For instance, look at this graph. First of all, let's check to see if it's one-to-one. So you're answering this question. I'm not one-to-one, my bad. And I shouldn't say it. That's a bad word. Is graph a function? That's the first question you're going to answer. Okay. So if I look at it, I can check for vertical line test, and I can check here, this vertical line touched one time. This vertical line touched one time. So according to the vertical line test, I'm going to put yes, it worked. It is a function. So option C is out. So I know it's a function, which part A and part B are showing here, but is it not or it is? So now what I'm going to do is do the horizontal line test. And here I automatically see that this horizontal line test is absolutely failing. It is definitely touching the graph more than once. So A is my answer. It's a function, but it's not one-to-one. This one over here on the right, as far as vertical line test, it's definitely passing. It touched only one time, so it's a function. As far as horizontal line test, drawing it anywhere, by the way, it only touched one time as well, so it passed both of them. So it is a one-to-one function. Okay, so that's all you have to do when it comes to those. All right, let's jump into composition of functions. how do we do these problems? So when it comes to composition of functions, all you do is start with this value right here. Okay? That value is your x. It's always going to be your x. So when it comes to this problem, by the way, let me clarify before I explain to you how to do this. This first problem only deals with these two graphs, okay? So I'm starting on the x-axis. I'm either going to start here on this -2 on the x-axis or on this -2 on the x-axis. But how do I know which -2 I'm going to start at? Well, I need you to look here at this g. And that g tells me I'm going to start on the right-hand side. So I'm going to erase this, and I'm going to start at the -2, and I am going to go to my g function. So at -2, when I go to my g function, I had to go 4 steps up to get to my g function. You will either go up or down from the x-axis. So that means, let me get my little pen here, it's not cooperating. I'm going to set equal to. The f, I haven't done anything with it. When I'm at -2 and I go to the g function, I went up 4 spaces. So all I did was work out this piece right here. Okay? That's all I did. Now I do this all over again. Okay? So watch how I'm going to erase everything here. I start over again. This here is an x all over again. And it says stand at 4. I'm going to stand either at this x4 or I'm going to stand at this x4. So which one am I going to stand by? Well, the 4 is next to the f, and my f function is right here. So that means I'm going to erase this one. I'm not going to stand on that graph. I'm going to go stand at the 4. So let me erase that. So I'm right here at the 4. Am I going up or down on the 4? Well, I'm already standing on the graph. I don't have to move anywhere. So the answer is 0. Okay? And that's all you do on that one. So far, so good? So now what I'd like you to do is I want you to attempt to do the next 2 on your own. Try this graph problem right here. Those 2 graphs go together. And then I want you to try these down here at the bottom. Okay. So go ahead and do that. Pause the video and come up with the values to those answers. By the way, evaluate means find the value, and that means your answers are always going to be a numerical answer, okay? Numerical answer. All right, so go ahead and do that. Okay, so here we go. Let's see what you did. Let me erase this piece right here. You started at -1. -1, where do I start? Well, I'm starting -1 on the f-axis. So I'm going to start here at -1. So I'm right here, and I need to go to the graph. And so in order to go to the graph, let me expand it here so you can see really clearly. If I'm standing right here, here's my little person. It's kind of freezing on me here. So here's my little person here, and I have to go all the way down. I have to go down to -6. That's kind of thick there, so it's hard to see. But hopefully you're seeing what I'm trying to show you, right? Let me use a different pen. You're here at -1, and you're going all the way down to -6. So let's come over here. And so this inside part, -1 on the F graph, says that you went down 6. So I'm going to bring the G over. I haven't used it yet, and I went down 6. Okay? And then I have to repeat the process again. I'm going to start on -6 on the x-axis, and I'm going to go use the G graph. So the G graph is on the other side. So I'm going to stand on -6. You always stand on the x-axis. And where do I have to go to the g-graph? I have to go up that much steps. And what is that steps? Those are, I had to go up 5. So that is 5. And that's all you do. And here we go with this one. Start on the 9 on the g-graph. So 9, I'm on the g-graph. Wow, I'm not sure what was happening there. So where's my g-graph? It's over here. I need to start on 9. So 9 is right over here. So I'm here on the 9 and I have to go to my g-graph. So let me stretch it here. So I'm here and I go all the way up till I hit it, right? And so all that distance here is how much? I had gone up 5 units. So bring over the F. I had gone up 5 units. Start all over again. I have to go back to a 5. So am I standing here? No, because 5 says stand on the F graph, and my F graph is over here. So I'm standing over here on the 5, and I need to go to the graph. So if I'm standing here, that means I am going to do what? I'm going up. How many units? 3 blocks. 1, 2, 3 to get to that graph. So f of 5 ends up being a numerical value of 3. Okay. All right, we're almost done here. Let's fill out this table of increase, decrease. So this is what I need you to do. I'm going to erase here for a second. Let's see if it's going to do it. There we go. So let me clear up this mess because I need you to do a little labeling. So instead of doing every single one of these graphs, because that would be a nightmare, write the A, B, and C labels right here next to this table. And I'm going to ask you to think of this as your A graph. This one's going to be the B graph. And this one over here, let's put C right here, is going to be your C graph. Okay? So when it comes to increase and decrease, here's the format that I always want you to know. Okay? The format is always going to be one where you will always have parentheses with a comma, and the values you put here is either going to be an infinity. Let me see. I'm going to put arrows here like this. You are either going to use negative infinity. I wish I would quit correcting myself. It would either be a negative infinity, a positive infinity, or an x value. Those are the only values you are allowed to put in those spots. Okay? So it's always going to be parentheses, and you will always put 2 quantities there. So here's how it works out. Let's look at A. Always trace your graph from left to right, okay? So when you trace your graph from left to right, notice over here, my left is this right here, okay? I'm putting my pen here or my thumb, and I'm going left to right. So I'm tracing, right? So what is happening to your thumb or your pen? Well, here, my numbers are getting high as far as Y's. They're getting higher. Then right here, they stop because all of a sudden they start going low. So what you're telling me is right after this piece right here, it was increasing. Quit correcting me. It was increasing. So I'm going to put INC. And then all of a sudden, it started to decrease on this side, okay? So the increasing actually happened, to the left of 7, and decreasing occurred to the right of 7. And when I'm talking about 7, I'm talking about 7 on the x-axis. Do you recognize that? So anything to the left of 7, those values were increasing when I traced it. And then after 7, they started to decrease. So what you're going to do in your notation for increase, decrease intervals is you're going to say, on the left-hand side, it increased. So from negative infinity all the way to positive 7, it was increasing. And then after 7 and to the right, it decreased. So you're telling the reader which half increased, which half decreased. So pause the video and do the next two, and then come back and check with me. Okay, you're back. Okay, so let's trace the graph. So we're tracing it from here, left, and then right. And what did I notice? I noticed that this side was decreasing and this side started the increase. Where did it change? It changed to right here, right? And that number is the number 6. So to the left of 6, it was decreasing. To the right of 6, it increased. So where did it increase? On my table, I'm going to write them in red here. So increased to the right of 6. So I have to say from 6 all the way to the right, it increased. Oh my goodness. There you go. Where did it decrease? So see 6 to the right. This is negative infinity. Where did it decrease? It decreased from negative infinity, comma, to 6. So notice here, like if you just look and use these numbers here, that's all you're doing. You're just using this right here. Oh my goodness, this pen is not working. You're just using these. So negative infinity to 6 was decreased. 6 to positive infinity increased. All right, how about over here? Let's use pink. From left to right, what's happening here? Increased. What's happening here? Decreased. So let's do that. Here it increased and here it decreased, right? Where did it change? It changed right there. That's at what? -3, right? So it's -3 left and right. So it increased to the left of -3. So from negative infinity to -3, it increased, and it decreased from -3 to positive infinity. So that's 1.3 for you guys. Hope that helps. And so go master this content by completing your Delta Math. Thank you so much for watching.